Alright guys, let's continue to probability and statistics today. So we're gonna talk about first regression. The regression is, alright, let's take unconditional Gaussian distribution. So if you remember about the Gaussian distribution, it takes parameter x and theta that create the specific property. So the property is what belongs to the specific distribution. In this case, what people call normal distribution or the Gaussian distribution, which has two properties. One is a mu and the other is the sigma square. So the probability function that is Gaussian can take those two parameters and it will create the normal distribution with mu and sigma square based on these two parameters, input and parameters, sorry. And this is the real value, so to say, and it's mu and it takes predicted variance, so that's what it says, mean and the variance that it takes. And when its variance is fixed and independent of the input, it is called homoscedastic regression. This concept further reduced to the model, it is called linear regression. So what is linear regression? Here we come. So this is actually the first, what people call the machine learning model, or maybe the statistical model, or even you can call it as AI, because technically linear regression is already what AI does. So here's the thing, the linear regression takes the weight, x first input. Let me pull it up with some sort of drawing. Okay. So the usual functions start with the fx equal y, or you can also say that y equal fx 0. So y equal fx, or you can say the other way around, but this is well-posed problem. So you take x and it flows to y. Now, linear regression case, so I'll put here. We take y is wtx plus b, and there is sigma square. So what it does, it is probably not so intuitive at first, but it is basically the AI. So if you maybe reduce this part, ax plus b, then you know this function. This is a standard model. So that in this case a is slope and b is intercept, and usually, I don't know, I'm trying to draw it. So duck, duck, and this is x, this is y. Oh, this is pretty similar. I will write this way. And this is 0. This is like infinity. This is minus infinity. This is plus infinity. And this is minus infinity. And in this case, y equal, so let's say 2x. So the 2x, x means that if x move 1, y move 2. So it will be like this point. Yeah? And then y equal to 4 when x is 2. So it will be this point. And plus 1 means this is created at y plus 1. So here. So if I describe again, y equal 2x plus 1. This is essentially to say when it's here, the y is here, and then you take 1x and it goes to 2y, x again, 2y, x again, 2y here. So distribution goes like this. And this is y equal to x plus 1 function. I can show you also the official graph and compare if it's correct. Yes, it looks like. So if you find some image in Google, the y equal ax plus b, in this case 2x plus y, is this distribution. So if I compare that side by side, exactly the similar function. And the case for w, so in the case that we have here, basically the w and sigma square, that is just to say that is just to say this is the matrix, so it comes the latest section. So why is the Gaussian distribution so widely used? The Gaussian distribution is the most widely used distribution in statistics and machine learning. There are several reasons for this. First, it has two parameters which are easy to interpret and which capture some of the most basic properties of distribution, namely its mean and variance. Second, the central limit theorem, tells us that some of the independent random variables have an approximate Gaussian distribution, making a good choice for modeling residual error or noise. Third, the Gaussian distribution makes the least number of assumptions, subject to the constraint of having a specific mean and variance, as we show in section blah blah. So yeah, so basically the function, the distribution function that we saw at beginning. All right, I'm gonna try to create it here. Not too sure how it's gonna work. Anyway, it's not a big deal. So the normal distribution is something like this, and here, and this is the mu, and this is the sigma square, and called the variance, and this is the mean. Well, of course, we wonder what the hell is this distribution? Why is it so popular? There aren't really, like, when I first also learned it, I was always curious why the normal distribution is very popular. The simple answer is it is happening a lot in natural phenomena. So our hate, so we put all the people in human, and statistically speaking, we put human numbers one by one, it creates this bell curve shape distribution. That is kind of mind blowing. There's like a lot of things that naturally occurs. It distributes this way. So we take those distribution and find the parameters, properties, and we measure it. And that's how the statistical probability theory works. This is kurtosis. The kurtosis is the well, all right, it's a Laplace function. So I'm gonna skip to the cauchy distribution now. The cauchy distribution is the Gaussian distribution, but with heavily skewed toward 95% of the value from a standard normal between for standard cauchy there. Yeah, so basically that's it is a skewed distribution, and you can think of it as the changing shape like this. So it will different shape. It will show the different shape based on the parameter gamma. And there is a Laplace distribution, double-sided exponential, beta distribution. Maybe these are not as important as what we discussed. Of course, these are important, but not as immediate sense. Yeah.